Challenge for you to write a program to check whether a number is prime or not. A prime number is a positive integer which is divisible only by 1 and itself. For example, 2, 3, 5, 7, 11, 13, etc. All you have to do to test whether a number is prime or not is to divide it successively by all numbers from 2 to n by 2. If remainder of any of these divisions is 0, the number is not prime. If none of the remainders returns in 0, it's a prime number. You can pause the video now. Good luck. Welcome back. I hope you managed that. If not, follow along with me. Create a new file in code blocks and save it as s4_08.c. Write the purpose of the program as a comment at top. C program to check whether a number is prime or not. Include the header file hash include open close angular brackets stdio.h. Write the main function int main open close parenthesis void as parameter open close curly brace return 0 semicolon. Declare three integer variables int n, I, flag equals to 0. Ask the user to type a number. Printf open close parenthesis semicolon within double quotes write enter a positive integer. Store the user input in n. Scanf open close parenthesis semicolon within double quotes %d for integer comma %n. Using a for loop, iterate through 2 to n by 2 for open close parenthesis I equals to 2, I less than or equals to n by 2 semicolon I plus plus. Check if the number is divisible by I. If n modulus I double equals to 0. If true, set the flag variable to 1 and break out of the loop since we have identified that n is not a prime number. Flag equals to 1 semicolon break semicolon. After the for loop, check if the number is 1. If n double equals to 1, printf semicolon within double quotes write 1 is neither prime nor a composite number. Else open close curly brace else if flag is 0 it's prime number, otherwise it's not a prime number. If flag double equals to 0, printf open close parenthesis semicolon within double quotes write %d is a prime number comma n. Else printf open close parenthesis semicolon within double quotes write %d is not a prime number, comma n. Here we have declared three variables n, I and flag. N is used for storing the number and I for the loop counter. We have initialized the flag variable with 0. Inside the for loop, we iterated from 2 to n by 2 using I, and every time we are checking if n is divisible by I with the condition n modulus I double equals to 0. The moment n modulus I turns out to be 0, that is n is exactly divisible by I, we set the flag variable to 1 and break out of the loop. After the for, we test the value of n with 1. If true, we print 1 is neither a prime nor a composite number. Else, we test the value of flag with 0. Flag is 0 when the loop terminates normally, because the value of I becomes equal to n by 2 plus 1. It means that there was no number between 2 to n by 2 that could exactly divide n. That is, n is indeed prime. So, we print the number is a prime number. Else, we print it's not a prime number. Press F9 to run the program and check with some prime and non-prime numbers. Let's start with 5, which is a prime number. Okay, 5 is prime number, gets printed out on the console. Let's run the program again. 4 is not a prime number because it is divisible by 2 also. 4 is not a prime number. Perfect. Thanks for watching. See you in the next lecture.